Welcome to the shop. Here we are at the old Bridgeport Interact CNC. Have a Centroid control on this. This is a retrofitted control. It's a lot newer than the machine is. And I decided that we were going to do the simple saddle piece first. So I have it here in the vise, and we are going to check the alignment with the indicator. So I'm going to run across this. And I've got it pretty well zeroed on that side. We're going to come to the other side and we're going to give it a little tappy tap tap. This is perhaps the cutest hammer you've ever seen. This is a Paschal Machinist or jeweler's hammer. It's a 1 ounce hammer. So let's give it a little tap, see if we can get it lined up. The vise might be a little tight. And just a little bit. We're going to call that good. Okay, so now we've got the edge finder loaded in the machine. I'm going to come down and pick up some edges here. Remember, we are going to take the front edge of the part, call that Y0, and then we are going to take the center line and call that X0, and then we're going to set Z0 on the top surface. So here we are, the edge finder's against the front of the part. I'm going to go to my part setup and I'm going to go to my Y-axis and I'm going to tell it that my part position is currently at minus 0.1. And so when we hit F10 to set, our Y position is now set for negative 0.1. If I were to jog my Z up, and if I were to bring my Y back so that it was aligned with the front edge of the part, I would be real close to 0. So now I'm going to bring my X to the left edge of the part, drop my Z, bring my Y back, and I'll start the spindle. And what I'm going to do is I'm going to pick up this edge, and then I'm going to come over here and pick up this edge, and I'm going to split the difference. So I'll qualify this as X0 initially, come over here, find that dimension, record the dimension, divide by 2, and then I will know where my center is. So I'll just call this whatever half that distance is, making the center 0. So looking at my X position, I have 2.941. So what I'm going to do is go to what my X part position is, and I'm going to split the difference for those two numbers. So half of that distance is 1.470 and a half. So where my part position entry is, I'm going to type in that this is positive 1.470 and 5, and we're going to hit set. So I just called the current position 1.470 and a half. 0 would be in the center, and on this side it would be negative 1.470 and a half, because I took that total distance I recorded with the edge finder, split it in half, and called this what one of those halves was. So that puts 0 right in the middle. So this is the holder that machine uses, and this is called a DA series collet. You're familiar with the ER series collet, but a DA series collet stands for double angle, and the collet has two straight diameters with a tapered angle on one side where my thumb is, and then a tapered angle on the other side. This goes into the seat of the collet. We put the nose nut on top. There we go. And we'll insert the tool to the right projection that we need, and then we'll snug it down and it'll be ready to go in the machine. Okay, so now we're going to qualify the tool, and I'm going to bring the Z-axis down, and I'm going to touch off using this piece of paper as a feeler. We're just going to come down on top of this surface. Get a light drag like that. And as I stated earlier, we are going to qualify this tool based on where the center of that ball is. So in other words, this is a 1/4 inch diameter tool, and I need to not qualify the tip but step up half of that 1/4 inch diameter, 125 thousandths would be the radius. And that's going to put the tool qualification point in the center of that sphere. I also have 4 thousandths for the paper to compensate for. So what I'm going to do is I'm going to set this as tool 1, and I am going to call the current position the 4 thousandths for the paper plus the 125 thousandths. So I'm going to call this Z.129. And so now, if I bring my Z-axis down to 0, I have the center of that sphere in line with the top of this plane. Okay? And I'm going to jog my X-axis to 0. And I'm going to bring my Y-axis to 0. And right now, the center line of the tool is aligned with the front face of the part. The center of the ball is aligned with the top plane of this flat. And the X-axis is centered in the part. All right, we're going to give it a try. I'm going to go ahead and load the program. I've already brought it up. This screen here will show a graphic representation as it's cutting. So we're going to go ahead and start the program. It's going to go to position. The spindle's going to start. And you can see the cutter moving across the part. Okay, so there we have it. I definitely have more projection with the tool than I need. And I probably would move those step overs to size less than 50 thousandths to get a better surface finish. But for the intent of showing you how 3D surfacing works, that is pretty good representation. A ball mill that had a bigger radius on it would also have produced a finer surface finish. But this did what we asked it to do. We could make some tweaks. We could go to a bigger ball mill. We could move to a smaller step over. But for all intents and purposes, it did what we asked it to do. So that's what it looks like with the step over reduced down to 25 thousandths. You can see the cusp height is much smaller. I'm going to drop it even a little bit lower, run it again, and see what it looks like. Okay, so here we have a receiver groove for the bushing that I'm going to lay into here. I worked from the center line in the positive direction. Now I'm going to work from the center line to the negative direction. Alright, so here's the end result. We have a receiver groove here that we're going to make a plastic bushing for. So I created a program with a different radius size, and I relieved this area using the same technique. And now this diameter, the bigger diameter, will give clearance with the tubing, and the diameter that's relieved is going to allow for a plastic bushing to be inserted in there and retained. So here we are on the old Le Blanc, and we're going to use a corner rounding end mill, and we're going to put that radius on the end of this bushing. I've just mounted it onto a piece of tubing so that we can hold it because it's kind of thin. So here we are, finished product. We can you can see we have the saddles all machined out. These pieces have the matching grooves in them, and so the bushing I turned out of a piece of PVC pipe. Maybe not the best material for it, but I had it on hand and it should work for what I want it to do. That clips right into the groove, has a nice fit. And when it's assembled, that ought to go on there just like that. So what I'm going to do next is I'm going to take the bushing and I'm going to slit it. I'm going to use a jeweler's saw, just try to put one slit in it and then try to stretch it over the roll bar tubing, and then this whole kit and caboodle will capture it, and hopefully it works the way I intended. Okay, so over here on the truck, I'm going to slip this on. I've put a slit in it, so hopefully I can spread that. There we go. Clips right over the tube. And that should go right over top. And then finally, if I had another hand, okay, so I put a slit in these and they slipped right over top of the tubing. So with that in place, I'm going to put this over top of them, capturing the bushing in the groove. And I drop one of the screws. one started. Now there's a latch mechanism that I made that goes in here. This has kind of a shot pin design. Notice the spring fits better one way than another. And then I can insert the other saddle. And I should be able to draw these tight. And there it is. Nice and smooth. Now I didn't put the other screws in here, but I don't anticipate that's going to affect anything by tightening those down. There's enough clearance in there, and everything moves nice and smooth when I go all the way closed. You see that pin drop in, locking it in place. And that works exactly the way I wanted it to.